Hello, so today I'm looking at M3 International A-Level May 2014. This is question 5. A particle P of mass 2m is attached to one end of a light inextensible string of length A. The other end of the string is attached to a fixed point O. Initially the particle is at the point A, where OA is of length little a, and OA makes 60 degrees with the downward vertical. The particle is projected downwards from A with speed u in the direction perpendicular to the string, as shown in figure 3. The point B is vertically below O and OB equals A. As P passes through B, it strikes and adheres to another particle Q of mass m, which is at rest at B. Show that the speed of the combined particle immediately after the impact is this thing, and this is worth 6 marks. So, if we begin by looking at the kinetic energy and the gravitational potential energy here and the kinetic energy here, and we'll take this level B to be the level where there is no kinetic energy. So, if I just quickly do a sketch of this, so here I have 60 degrees, and so when the particle is here, then I'll call this H, and so I have the kinetic energy at A plus the gravitational potential energy at A equals the kinetic energy at B, taking this as GPE is 0, so there's no gravitational potential energy here, so I'm measuring everything from here. So I get half times the mass, and the mass was 2m, times the initial speed squared, plus the mass times g, times the height above b, and so that will be a minus a cos 60, so just this part here is a cos 60, so I have a 1 minus cos 60, that is this height here. Then it will equal half times the mass, which is 2m, times the velocity at b, which I'll call v, squared. Okay, I can see that I have 2m's all over the place, or in fact m everywhere, so let's divide everything by m. These two cancel, and so I get v squared is u squared plus 2ga times 1 minus cos 60, but cos 60 is a half, and so 1 minus a half makes a half, so in fact that will cancel with this. Okay, so the 2 and this thing cancel. Okay, so that gives me an expression which links v squared to u squared. Now, it says show that the speed of the combined particle immediately after the impact is this. So we can use the conservation of momentum to work out what the speed immediately after the impact is. So basically I have the particle which is 2m, and then this particle which is m. Initially m is at rest, and then 2m is moving with the speed v, which will be this thing square rooted. After the impact, then they'll move off with a common speed, so I'll call that w. And now, using the conservation of linear momentum, then I can write down the momentum before the impact, which is 2m times v plus m times 0, so that makes nothing, equals the total mass 3m times w. Remembering that v is going to be the square root of u squared plus ga. So here I can cancel the m's. I can work out that therefore w is going to be 2/3 of v, and v was the square root of u squared plus ga. So then I just need to look at the answer that they thought it was going to come out to. Oh, phew, they're the same. Okay, so that is your first 6 marks, and that is part A. So now it asks me in part B, find in terms of A, G, and M and U the tension in the string immediately after the impact. So if I look at what is happening in that moment, so here's O and here's this position B, and now I have a mass of the 2m plus the m, so I've got 3m is the mass, and so 3mg will be the weight. I have the tension acting in this direction, and there will be an acceleration towards the centre of the circle, which will be the velocity at that moment squared, so what I've called w squared, divided by the radius, which is a. So remember, in any circle question you can use r omega squared or v squared over r, and in this case, because we've got the velocity squared, then this is the best choice for the acceleration in this case. So now I can use Newton's second law to write down an equation. So I've got t minus 3mg equals the mass, 3m, times the acceleration. So the acceleration was the speed that I got before, so this thing, squared, and then divided by a. So I'll pop the divided by a there, and if I square this this expression, then I will get 2 squared makes 4, 3 squared makes 9, and that squared will make u squared plus ga. And so now I can just rearrange this as I'm looking for t. So t will be, let's see what will happen. So I will get, goodness gracious me, this is quite a mess. Right, okay. Oh no, it will simplify a little bit. Okay, so first of all, this will cancel with this and give me a 3 on the bottom, dividing the top and bottom by 3. Then if I multiply this out, I will get 4mu squared over 3a, and then plus I've got 4m over 3a multiplied by ga, and so the a's will cancel, and then I will add 3mg to both sides. And so just tidying this up a little bit, then okay, let's leave it like this. So I've got 4mu squared over 3a plus a load of mg's. So I've got 3mg plus 4/3 mg, and 3 is 9/3, so I've got 9/3 plus 4/3, which will make 13/3 mg. And remember, if you're under stress in an exam, it's always a good idea to just double check this on your calculator. And okay, that's given me 13/3 mg. So have I done what they said? In terms of A, G, M and U, find the tension immediately after the impact. Okay, so that's part B, which is worth 3 marks. In the last part of the question, it then says the combined particle moves in a complete circle, show that u squared is greater than this thing. So we know that if it moves in a complete circle, then it means that the tension when it reaches the top is greater than or equal to 0. And so if I examine what is happening when it's actually at the top now, so here is 0 in this center, and this is the kind of critical moment when it's here. So I've got the weight, which is 3mg, plus the tension. I'll use T dash because this is different to the tension that I had before when I was looking at a different position. And this will equal the, and in this, towards the center of the circle, I will have the acceleration of whatever the speed is in that moment divided by the radius, which is still a, and I've already used u, I've already used w, did I? Yes, I used w. So let's call this speed here x when it's so when its speed is x, then the acceleration is x squared over a. Okay, so I can use Newton's second law, and the forces towards the centre of the circle, 3mg plus t dash, will equal the mass, which is 3m, multiplied by the acceleration, which is x squared over a. And I know, therefore, that the tension will be 3m x squared over a minus 3mg. And I know that that tension must be bigger than or equal to 0 for a complete circle to happen. So now I need to get rid of this x squared. So the other way that I can get an expression, or sorry, an equation with x squared in, is to look at the energy. So I could say that if I call this point up here C and the point down here is B, then I know that the kinetic energy at B will equal the kinetic energy at C plus the gravitational potential energy at C. So the kinetic energy at B is 1/2 times the mass, which is 3m, times by the velocity squared, and the velocity squared is this thing squared. So again, I get 4 over 9 u squared plus ag. So that's the all of that is the kinetic energy at B, will equal the kinetic energy at C, so 1/2 times the mass, which is still 3m, times by what I called x here, so x squared, plus the gravitational potential energy, which will be the mass, 3m, times g, times by the difference in height from B to what I've called C, which is directly above that. It's 2a above where C is. So I can see I have 3m everywhere, so let's divide through by that. I need to get rid of this half, so I will double, double, and double. And now I've got an expression for x squared. So if I just tidy this up, this is x squared, this is 4ag, this is 4 over 9 u squared plus 4 over 9 ag. And then I can rearrange this, taking 4ag from both sides to give me a kind of neater expression for x squared. So I get 4 over 9 u squared, and then I'm doing 4/9, take away 4, so 4/9 take away 4, whoops, 4/9 take away 4, and that gives me negative 32/9 ag. Because essentially here you're doing 4/9 take away 36/9, which will give you negative 32/9. Okay, so now I can pop this expression in the place of x squared here. So I know that this thing that I call t dash, this thing here is bigger than 0. So t dash is bigger than 0, therefore I've got 3m over a multiplied by my expression for x squared, which is 4u squared over 9 minus 32ag over 9. And we're up to here now. Minus 3mg will be bigger than or equal to 0. And I'm looking for an expression for u squared. Okay, so I could divide everything by m, and 0 divided by m makes 0. I can add 3g to both sides. Then, oh dear, I could have got rid of the 3's as well, actually. Okay, so in that case I add g to both sides. Let's just write out what this will make. So here I get 4u squared over 9a minus 32ag over 9a, so those a's will cancel. And now I get 4u squared over 9a is bigger than or equal to, and now I'm going to add 32/9 on to both sides. So I get 32/9 plus 9/9 will make 41/9 g. And just Remember, in an exam, I'm under pressure, so let's not take anything for granted. Okay, 41/9. And now I can multiply both sides by 9. And I can multiply both sides by a. And divide both sides by 4. So just tidying this up, I get u squared is 41ga over 4, and therefore I'm actually looking for, yes, exactly that. U squared is 41ag over 4, phew, as required. Okay, so that part of the question is worth 4 marks, so you've got the 6 marks. So you've got the 6 marks from part A, 3 marks from part B, 6 marks from part C, and so altogether you've got 15 marks for that question. Okay, I hope you found that solution helpful. Good luck with your revision, and do click like if you liked it. Until next time, bye.